Good morning, dear students. Welcome to Narayana online classes. For class 8 students, today's topic is SP3 hybridization. SP3 hybridization. The definition for SP3 hybridization, if you take here, one s atomic orbital is mixed with 3p atomic orbitals and it forms 4 equal number of SP3 hybridized orbitals will form. 4 equal number of hybrid orbitals will form. Means here in hybridization, how many number of atomic orbitals are combining, those many number of hybrid orbitals will form. Now in this hybridization, one s atomic orbital is mixed with 3p atomic orbitals and it forms 4 equal number of sp3 hybridized orbitals will form. Now here in this sp3 hybridization, the percentage of s character if you take, it is nearly 25% will be there. Remaining 75% p character will be there. And here the one more name for this sp3 hybridization we can take as it is tetrahedral hybridization I can take. Generally here like CH4 molecule if you take, the shape of the molecule is tetrahedral shape. Now for example, now here if we come to the examples related to this sp3 hybridization, here the first example I can take as CH4 molecule. Okay, and here second example I can take as it is ammonia molecule, and third example I can take as like water molecule. Now here if you see the examples, in central atom in CH4 molecule, here there is no lone pair of electrons, and here if you take in ammonia molecule, nitrogen is having one lone pair of electron, and in water molecule 2 lone pair of electrons. Now these three are the examples I can take for sp3 hybridization. Now in detail we will discuss here. Now first example I am taking as CH4 molecule. Now CH4 molecule, if you take the central atom is the carbon atom, and if you come to the electronic configuration, it is 1s2, 2s2, 2p2, and the outermost orbit I can take as it is 2s2, 2p2. Now here this carbon atom is bonded with 4 hydrogen atoms. It means here for the bond formation only unpaired electrons will participate in the bond formation, not paired electrons. Means here 4 bonds means in that carbon atom, in the ground state electronic configuration if you take, here s orbital 2 electrons are there, in p orbital also 2 electrons are there, but we required 4 unpaired electrons for the bond formation with the 4 hydrogen atoms, but we have only 2 unpaired electrons are there. Now here if we come to the excited state electronic configuration, the opposite electron will be jumps to the empty orbital. Then here each orbital is having 1 unpaired electron. Each orbital is having 1 unpaired electron. Then here how many hydrogens we have? 4 hydrogens are there. Then each hydrogen atom will give 1 electron for the bond formation. Here 1 electron, here 1 electron, here 1 electron, here 1 electron. Now here, now 4 hydrogens are bonded with the same carbon atom. Then here it can form 4 bonds here. It can form 4 bonds here. Then here, now 8 electrons are there in the valence shell for that carbon atom. 8 electrons means which stability? It is octet stability. Then here, all are bond pairs only. There is no lone pair of electrons. All are bond pairs only. Now lone pair of electrons and bond pair of electrons we will consider only in the valence shell. Inner electrons are not considered. Inner electrons are not considered. Now here all are bond pairs only in CH4 molecule. Now if you come to the shape of this molecule, if you take arrangement of atoms, if you take in the space, here like a tetrahedral shape arrangement will be there. Here like a tetrahedral shape arrangement of atoms will be there. And here the bond angle between hydrogen, carbon, hydrogen if you take, it is nearly 109 degrees 5 minutes will be there. 109 degrees 5 minutes will be there. Okay, now the shape of the molecule is tetrahedral shape and the bond angle is 109 degrees 5 minutes will be there in CH4 molecule. Okay, this is one example for sp3 hybridization. Now come to the second example, it is ammonia molecule. Now here if we come to the central atom as nitrogen atom, here in this ammonia nitrogen electronic configuration if you take, it is 1s2, 2s2, 2p3. The valence shell I am taking as 2s2, 2p3. Then here 2s2 means 2 electrons, those 2 are paired electrons. 2p3 means all are unpaired electrons only. Now it is forming NH3 molecule, nitrogen atom. Means 3 hydrogens means how many unpaired electrons will be required? 3 unpaired electrons will be required. Means each hydrogen atom will give 3 electrons for the bond formation. Each hydrogen atom will give 3 electrons for the bond formation. Means no need to go for the excited state electronic configuration. Then here 1, 2, 3. Already 5 electrons are there, then 8 electrons are there. 8 electrons means octet stability is there in the NH3 molecule. And here 3 are bond pairs and 1 is lone pair of electron, which are not participating in the bond formation. We are taking as non-bond electrons or lone pair of electrons I can take. Then here, if you come to the shape of the molecule, 1 lone pair is there, 3 bond pairs are there. And here, the shape of the molecule, it is like a pyramidal shape, and here it is like a pyramidal shape, and here the bond angle it is I can take as it is 107 degrees will be there between hydrogen, nitrogen, hydrogen I can take as it is 107 degrees will be there. 107 degrees will be there. This is one more example, and here the shape of the molecule it is pyramidal shape, but in CH4 molecule it is tetrahedral shape. Why the difference is there? But hybridization is same. The difference is what? There in CH4 molecule, carbon atom is surrounded with 4 bond pair of electrons, but here nitrogen atom it is bonded with 3 hydrogen atoms with 3 bond pair of electrons, but 1 lone pair is there. But lone pairs will not participate in the shape of the molecule. Then the shape of the molecule I can take as it is pyramidal shape. Now come to the one more example, that is water molecule if we take. Now in this water molecule, the central atom is oxygen atom, and if you come to the oxygen electronic configuration, 1s2, 2s2, 2p4, outermost configuration is 2s2, 2p4, here 2 electrons, 2p4 means here 1, 2, 3, 4. Now here this is the ground state electronic configuration. Here oxygen atom is having 2 lone pairs and 2 bond pairs are there. In the formation of water molecule, 2 hydrogens are there, no? Means each hydrogen atom will give 1 bond for the 1 electron for the bond formation. Then 8 electrons means octet stability will be there. Okay. Now here these 2 are bond pairs. What about these 2 remaining 2 are? These 2 are lone pair of electrons, which are not participate in the bond formation. We will take as lone pair of electrons. Now here, if you take a water molecule, here 2 hydrogens are arranged like this, and 2 lone pairs are there. Now lone pairs are arranged like this. Lone pairs will not participate in the shape of the molecule, and here the bond angle between hydrogen, oxygen, hydrogen, it is 104 degrees 5 minutes will be there. And here, this is also I can take the example for SP3 hybridization, and the shape of the molecule it is V shape or bent shape. V shape or bent shape. We discussed with 3 different examples, and here 3 different shapes of the molecules and 3 different number of lone pair of electrons and bond pair of electrons, but hybridization is same. Means hybridization is same, but here only the difference is what? Number of lone pair of electrons in the central atom and number of bond pair of electrons in the central atom. Okay, like this we can discuss. Now examples, if you take CH4, NH3, H2, right? Now suppose one question they asked, which of the following molecule is having which of the following molecule is participating in SP3 hybridization. Now first option CH4, second option NH3, third option H2O, fourth option all the above. Then what I can take? Fourth option I can take. Okay, suppose for example, second question asked like this. Now in the central atom, which of the molecule is participated? How many lone pair of electrons and how many bond pair of electrons present in the central atom? Okay, now options if you take CH4, NH3, H2O, lone pairs and bond pairs both are there. Which of the following examples I can take? Here water molecule lone pair is there and bond pair is there. In NH3 also lone pair and bond pair is there, but here only bond pair of electrons is there. Okay, now I can take second and third options I can take. Fourth option all the above suppose. Okay, suppose which of the following molecule is formed due to the only bond pair of electrons? Now options are once again same. Then I can take only CH4 molecule. Remaining 2 are lone pair and bond pair. No, only one example like a CH4 molecule I can take. Okay, this is about SP3 hybridization. Thank you.